Hello everyone. So today we'll just discuss some of the problems you can say, or maybe the concept if you are having any doubts. Okay. So okay. So I'll just first remind you. So the 11th week content has been released. Okay. And the 11th week there is like one folder would be there that consists of recap of week 11. Okay. So that will be consisting. Are you able to hear me, right? Can somebody say anything?
Yes,
Yes,
sir.
sir.
Oh, okay. So 11th week content has been released, and one folder will be there that will be recap of week 11. So that will be consisting of most of the stats part that you already have read in stats 1 or 2. That will be related to discrete, so basic probability stuffs, and that will deal with the discrete variables and all. And then when you will come, so there won't be any practice and graded in the week recap of week 11. Okay, so there will be activity. If somebody is good in probability, you can just go to the brief, and then you can just come to the week 11. 7 lectures should be there. You can go through that, and then so week 11 will be consist of most of the continuous part. Okay, and the recap will consist of the discrete part. So you can just go through that and then take practice, and graded will be consisting of both discrete and continuous both. So you can just, I don't think so there will be much issue because you already have solved those problems in stats 1 and 2. And those are not that difficult as stats 2, just a recap. So I don't think so much time will. So next week we'll be having the session for week 10 and week 11 both, I guess, because we are not having any session related to week 7 this week because of the quiz. We'll having from next week, maybe from the Wednesday, we'll be having 4 or 5 sessions. That will be consist of week 10, and then we go to week 11. And the week 11 deadline would be a bit late because there are so many questions in week 11. So the deadline would be, I guess, will be released, and the deadline will be similar to as I think so week 12. You'll get the notification regarding that maybe in upcoming days. Okay, so now we'll start with this one. So first, okay, I'll just share my screen. Okay. So, okay, tell me what is the doubt? Like one doubt is there related to, I think, so PCA, this concept, right?
Yes, sir.
Projected data set.
Yes.
Okay. So what are the doubts in this? Can you specifically say? So there is some error in that what do you say? Because I need to like again we have to make the slide. That this time we didn't prepare, so the person who has prepared is not available now. So that's why all the codes of this tutorial has been like his mail and all has been deactivated. So we don't have the source file of this. So we need to write it again. That's why we were not able to like edit this wherever there was a problem. So yeah. So where is that? Where is that issue? So week 7,
Yes.
right? Week 7. And is the tutorial okay? So what was the confusion here? I think so. This formula, right?
Yeah, exactly. That was the confusion over there.
Okay. So I don't know why there's a confusion in this. So when we are
Because,
okay, yeah.
yeah, because in the lecture, like you have the full form there, right? Like with both alpha and beta,
Yeah.
right? Like you have, but then over there, it just says that the alpha component is considered. So I, like in my, uh, like my way of thinking was that the portion in which we use just alpha, that is alpha uj, that is the projection to the lower in the lower dimension. So that
Yeah.
might be the projection that we use for the actual calculations. But
Mhm.
the full set, that is the one including the beta uj, That is the one which we consider for like calculating the reconstruction error to check how good our PC was or something.
Yeah, correct. So see, if I have to see, I'll tell you now that the mostly you'll get the problem if you have to solve. Like, okay, apart from the problem, if you have to reduce it from some 10 dimension to 3 dimension, then you can use this formula, whatever the sir has told. Okay. If you have to reduce every time, this formula can be used. But if you have to reduce this to one dimensional, right? So if you're having one dimensional, that means you have to consider all the other vectors as zero, right? Only one
Yes.
vector, most the vector which are having corresponding to the more like highest or the largest eigen values you have to consider. Other than that, you have to consider all the other vectors as zero. Okay. So when you will consider the other vector as zero, this the other part will become zero. Okay.
Yes.
How does that become? Because see, when you'll get the d as one, right? Because you have to if you have to reduce that to a one dimension, just you can what somebody is asking. Please take a good example. Okay. Okay. So if you have to reduce that to one dimension, so don't consider the second part first of all. The first itself, so I'll solve one problem, maybe the same problem that is there in the tutorial, right? Like here, so here,
Yes.
so many mistakes are there. Like the covariance matrix is also not like solved correctly. So the eigenvalues
Yeah.
is 14 upon 3, 0, 0, right?
Yes.
So,
Yes.
but the eigenvector, you'll get the same. So the eigenvector, because this is the highest, right? Because this should be the highest always,
Yeah.
because if you are dividing with 3 also, this is the highest eigenvalue. And corresponding to this eigenvalue, we have this eigenvector. And other vectors will consider as, that this is not important for us now. So this is the base formula is what? So xi transpose u, and then that is the projected thing. Then you have to apply the same, multiply the same thing with the ui. So you need to
UI.
write
Yeah.
it like this. So don't get confused in the exam. So you can expect some problem from the PCA, okay, and the same type of problem, because the computational will become very difficult. So you'll expect the same type of problems. You'll be given some sort of values, random x1, x2, x3, okay, and then some data set you'll be given, okay, and that you need to reduce it to some one dimension, okay, and so in one dimension you need to calculate the mean, that you won't face any issue, and then the covariance matrix. So to calculate the covariance matrix, please multiply this 1 upon 3 inside the matrix, or after calculating divide it by the 3. That's the one
Yeah.
thing, that's the mistake in the tutorial. So please don't do the mistake in the exam. uh, that's the one thing. So covariance matrix can be calculated directly. Okay, so that is the one thing. And then you'll be asked to calculate maybe the eigenvalues of the covariance matrix. Okay, that you can calculate. And then the other, okay, yeah, one thing, when you will be asked to calculate the covariance matrix, divide all the element with 3. Okay, if this is A, B, C, D, don't write the answer directly as A, B, C, D. So you need to divide each. So you'll not get any options if you are not dividing with the 3. Okay, that's the one thing. And if you have to calculate the eigenvalues also, you need to do like this: A upon 3 minus lambda, and then B upon 3, like this. And then you need to expand to get the eigenvalue. That's the other thing. The other thing, okay, the projected value. So we'll be having x1, okay, data set we'll be having. So you can just do x transpose into ui, okay, and then multiply with ui, because you have to. So don't, because most of the problem we have practiced also. We have transformed 3-dimensional or 2-dimensional to 1-dimensional. So every time we'll be using this formula. So don't get confused with the other formulas till now, because we had an exam is on day after tomorrow. So please use this formula. If you have to if you have to what you have to reduce from like multi-dimensional to one dimension. The projected data set you can get directly with this formula. So whatever the data set you're having, x1 or x1 you're having, so just transpose it, multiply with the eigenvector, you'll get some constant, and then multiply with the ui. Okay, you'll get the projected data set, right, or the transform data set.
Yes.
So this and the reconstruction error you can calculate. So the formula that has been written everywhere, the summation directly, it's not the summation. You need to divide it with the 3. right? If the data set is in the 3 dimension, okay? So divide it with the 3, and then you'll be having the X, the earlier data set and the newer data set, okay? So the transform data set or the projected data set you are having. So do this square and then divide it with 3, you'll get the reconstruction error. Okay, till now is there any confusion in this?
So in this, like while calculating J as well, like it is including the beta, right? The X tilde is including the beta, right?
X tilde is not including the, here the X tilde will be same as this one that we have calculated, the projected or the transform data set we have calculated, right? X tilde. So the same X tilde we are using, because we are, if I'm having, if this is the eigenvector and this is a projected thing, so we are just calculating the this error. If this was the original data set and if this is the transform data set for me in this eigenvalue in this direction, because we are just taking only one direction. So if this is the eigenvector in which eigen direction or the direction in which we are having the maximum variance, so we are just projecting the data set on this this what you can say, the vector or the direction, and then this error we are calculating. So this error you can calculate the squared form of that and then divide by 3, just to, because we are having 3 dimensions.
Okay, because like my doubt was like when it comes over there, because when we take the dimensions of the space that we take it to, we are actually having it at a lower dimension, right? So I was having this confusion whether like calculating the error on that on the basis of that lower dimension would be like correct or something. So for this case, like we just need to take the alpha part of it.
Yeah. The same part or the projected data set, whatever we have calculated. So now, okay, it's fine that you are thinking about the alpha and beta, but now just remove that beta part till now. Okay.
Hello, sir.
Yeah.
The projection xi tilde is equals to xi transpose ui, or all the time it should be u1, because in some it's always u1, which is the
Yeah.
highest
So,
value
okay.
eigenvector.
Yeah. So if you have to transform, if you have to calculate this x, this is x1, right?
Yeah.
Let, for example, this is the x1. So this is the, so the x transpose it will be what? This is x transpose we are doing for the
X1.
x1. So
Yeah.
x2, if you are calculating, the vector will be same, because in this direction only we are projecting all the data sets, right?
Okay.
This is the direction according, like corresponding to the maximum eigenvalue, right?
Okay.
So we are not considering other vectors for now, because we are just transforming to a single dimension. Okay, so you'll be
Sir,
using this formula every time.
this
Yeah,
eigenvector we have to normalize, right?
yeah, you have to normalize this eigenvector. So whenever you'll calculate the from the covariance matrix, calculate the eigenvalues and then calculate the eigenvector. So eigenvector we need to normalize. So whatever is there, you need to normalize that eigenvector. So whatever you are getting A, B, C, so just do it A square plus B square plus C square. Okay, to get the normalized form.
In week 3, projection of b onto a, it should be b dot a divided by a dot a whole dot a, right? So here we don't divide that by u dot uy.
It is orthonormal.
Yeah.
Okay, so u dot u is 1. That's why?
Yeah, yeah.
Actually, you already divided, because when you are calculating this, I mean, converting that to normalize, on that time that A transpose A. Sir, one more thing.
Yeah.
If the matrix is given 3 cross 3, okay, so for 2 cross 2 to calculate this means, oh no, have you means will you discuss the
some
SVD?
problem and then we can discuss the some your doubts. I'll just go through the same type of problem, just like whatever was there in the quiz. Okay, so you can expect those type of problems. Okay, and then you can ask you the doubt. Is that fine, or should I take your doubt first?
But sir, yeah, no issue, sir. But in quiz 2, there is no problem from week 1 to 3 or 4.
Yeah, there won't be any question. Don't worry about that.
Okay, okay.
there can be question like to calculate the eigen, like for example, the same covariance matrix, you need to calculate the eigenvalue. So if somebody can ask, somebody can come and say this is from third week. So that's why I'm putting everywhere. So you can expect the concepts from week third and fourth. Because last time what happened, some people just started calling like this is a question from week third and fourth. So I was like, oh, so then okay, this time I'm just putting it like this way, so that nobody can like say that this is from, you told the concept will be from fifth to eight, and then you ask the concept of week third. So that's why I'm putting like that. Otherwise,
I have a small query in SVD. So when you go to that SVD, I will discuss.
Oh, okay. So okay, so this is a practice problem. So if you're having any, so from week and 6 and 7 only I'm discussing. The rest I guess has been discussed by now. So like for example, this is a question. You have one vector a that is -133. Okay, can somebody tell me the eigen value of A transpose A? A transpose A.
Excuse me, sir.
Yeah.
So mainly the
eigenvalue,
questions, mainly the
Okay.
questions will be from week 5 to 8, no?
Yeah. So all the question will be from 5 to 8. Nothing will get from 1 to 3, 4 week. But third week, like some concept can come like eigenvalues or some sort of problem, because that has been discussed already in the 6th week also. Right.
Yes.
That's
Yeah.
it. So
So can we ask our doubts from some graded and mock questions?
yeah, you can ask. So mock, I guess the solution has been uploaded now.
But sir, there is some doubt also in the solutions also. So
Okay.
in the mocks. So if you can discuss it, it will
Yeah,
be fine.
I'll discuss that. So first, we'll just solve this 6 or 7 problem. So this type of problem you'll
Okay,
expect from the exam. So,
yeah, okay, sir.
if you're having this vector, okay, how will you calculate the eigenvalue? So first tell me how many eigenvalues you'll get of A transpose A. So this is 3 cross 1, right? Or 1 cross 3.
3 cross 1.
Okay. So what you will get the eigenvalue? So maybe I will do it. So calculate the eigenvalues of A transpose A, not A transpose. Is there any audio issue? So my voice is clear, right? Or you're having any
Yes,
issue?
yes, it is clear.
So I guess Vinod or somebody, yeah, Vinod, I guess it's not from my side, maybe it's from your side. Can somebody say how will I calculate this?
We
So do we
You
have
can just
matrix
calculate.
A transport and then calculate the eigenvalue.
So you want me to do this, right? So -1, 3, 3, and then calculate this -1, 3, 3, like this. This 3 cross 1, and this 1 cross 3. So you'll multiply, you'll get 3 cross 3, right?
Right.
And then you'll calculate the eigenvalue. How much time? It will take a lot of time, right? Maybe some other method you can say.
A transpose say without say.
Okay. So see, the eigenvalues you'll get of A transpose A will be same, right? That we have already discussed in the SPD also, right? Because whenever you are having M cross N and then you're having M as small or N as whichever is small, you can just do with that, so that you'll get the eigenvalues. Like if I'm having this was the problem, right? So this is 3 cross 1, and if you'll do this, you'll get 3 cross 3. So from here you'll get what? You get 3 eigenvalues. Okay, fine. But if you'll do A transpose A means 1 cross 3 and then 3 cross 1. So you will get only 1 cross 1 as a value. So whatever is the values we are getting, that will be the eigenvalue, right? Because we are getting only one element in that, and that will be the eigenvalue of that. Because 1 cross 1 matrix, what is the eigenvalue? Lambda minus whatever the you are getting, A equals to 0. So lambda equals to A will be the eigenvalue. So what you can do, whenever you are having one as a bigger and one is smaller, so just try to solve this in a smart way, so that like the guy he has told A transpose A, and if I calculate A transpose A, it will become very simple for me to calculate the eigenvalue, because we'll get only one eigenvalue from here and the other eigenvalues will be 0, right? So here from here also we'll calculate 3 cross 3 will be a bigger matrix, and then we'll calculate the eigenvalue. But the only one eigenvalue you'll get in the form like non-zero, and other two will be 0. Okay. So this should be there in your mind while solving the problem or the quiz questions. Okay. So this I'm repeating for the second time. So please be aware of this. So now if you're having any doubt, how does that eigenvalues and all become similar, you can ask. Otherwise, you'll go to the next problem.
So
So
for
we'll
this type
find
of matrix, when A is having a only single column,
What? Can you
always
repeat that?
for this type of matrix, say, or vector, A is equal to this only one single column, we always get the only one eigenvalue, right? Whatever the
Okay.
formation.
Yeah. So if you're having this type of problem, like only one vector and all, you'll get only one eigenvalue every time. But that value you need to calculate. Okay, that value you can calculate, right? You can just do the A transpose A or A transpose, whatever is suitable for you, right? Like if you are having the A as this one, -1, 3, sorry, 1, whatever the value is there, then you can do A transpose directly, right? That will give you 1 cross 3 and 3 cross 1. So I'm repeating this again. So somebody is asking me to repeat that. I'm just telling you, whenever you get the the matrix in this form, like in the singular, you are having only one column or one rows. And if you have been asked to calculate all the eigenvalues, so they'll ask you to calculate the eigenvalues in such that you have to calculate all. So if you're not solving this smartly, you have to solve whole, like I asked you for A transpose, right? A transpose. So if you solve this, you'll get a 3 cross 3 matrix. And then you're solving this, the eigenvalues and all, you'll get 3 eigenvalues for sure. And that will take your time, like it will take you 5 minutes, right? And if you're having 15 problems, it will become very difficult to solve in 1 hour. So it's better to solve in such a way such that you'll get a matrix. Like if you're having, like for example, if you're having this 2 column matrix, okay, so just arrange in this form so that you'll get 2 cross 2 matrix. And then in the easier way, you can calculate the eigenvalue, right? But like if I'm giving you 5 cross 2 matrix, I've given you. So it's better to solve 2 cross 2 matrix than 5 cross 5 matrix, right? So this is what I was saying. I think this is clear to everyone.
Yes, sir.
so sir, in this question, we also have to calculate the eigenvalues, no?
Yeah, you have to calculate the eigenvalue. If you have been asked to calculate the eigenvalue,
So
you have
using
to, using this, what? Your voice is not clear. I guess this for me only, or
yeah,
sorry.
using that characteristic polynomial.
See, if this is the
So
equation,
is it
and
clear now?
yeah, now it's clear. So if you have to okay, tell me how will you calculate the eigenvalues for this equation, this matrix? If you are having A as this matrix, if you have been asked to calculate A transpose A, so you'll get what? You'll get this matrix, right? So the matrix, what matrix you'll get? You'll get the matrix. I guess this will correspond to 8, right?
Yes, sir.
Okay. Okay. So this is the eigenvalue, right? Because if you'll go through the simple concept, how will you write 8 minus lambda? 8 minus lambda equals to 0. So lambda should be equals to 8, right?
Yeah.
Okay. So this is the eigenvalue for you. Right?
And so for 3 cross 3, we have to make the characteristic polynomial and then we'll have to solve.
Yeah. You have to solve all the equation, then only you'll be able to solve.
Okay.
So for 3 cross 3, it will become difficult. Again, you need to write, like, for example, here, for some example.
But sir, here if we are asked for A into A transpose, then we'll get 3 cross 3 matrix and we have to solve for 3 cross 3 only. We can't solve for 1 cross 1 then.
What? Can you repeat that?
Yeah, but sir, here we have to find the eigenvalues of A transpose A. So A transpose A will be 3 cross 3 matrix, and we have to solve it using the characteristic polynomial.
No,
We can't find.
I was saying. Okay, this is what I
Yeah.
was saying. See, if you have to calculate for A transpose, so you'll get 3 cross 3, right?
Yeah.
So don't calculate like this, okay, because you'll get, see, we have already discussed in the SPD, right? Like if you are calculating A transpose A and A transpose, so you'll get the same eigenvalues you are getting every time, right? Like,
Yes, sir.
okay, so A transpose A or A transpose, so both will be having the same eigenvalue. Like for example, here this is mistake. I'm guessing 1 plus 9 plus 9. So this is 19, non-even.
Yeah,
Okay.
it's 9.
This is error. So okay, fine. But the eigenvalues is 19 here. So from here also you'll get the eigenvalues as 19. One eigenvalue as 19 and the other two as 0, 0. Okay. So from here. So this is a good way to solve this, right? If you have
Yes,
been
sir.
asked to. Okay, so that is what I was saying. So if in the exam, if you are getting the matrix in the form of like 5 cross 2, so don't go with 5 cross 4, 5. It's better to go with 2 cross 2 and calculate the eigenvalues. And if you have been asked to sum the eigenvalues, you can do the all summation of both the eigenvalues, right? Because in the 5 cross 5 also, we'll face a bigger issue to solve that equation. It's better to go with 2 cross 2 and solve the eigenvalues. So in the both the cases, you'll get the eigenvalue the same. In the 5 cross 5, you'll get two eigenvalues as non-negative, non-zero, and the other three as zero, right? So you
Yes,
can
sir.
do in that way.
Okay, sir.
Okay, so fine. So this is done. So please revise this, try to solve this. You can expect some problem like this, and it will help you in the exam for sure. I'm betting you. So please practice. Okay.
Sir, sometimes answer of SVTs are given as Q1 sigma Q2 transpose, and sometimes they are in Q2 sigma Q1 transpose. So, is there
Can
any
you repeat that?
like
Maybe my like AirPod got disconnected. Okay, can you please repeat that?
sometimes SVD is given as Q1 sigma Q2 transpose,
Uh,
and sometimes they are like Q2 sigma Q1 transpose. So,
no
which one
worry.
is Q1 and which one is Q2?
Okay, it's fine. Like you'll get the okay. It's like for
It
example, if
will be
you're getting
always optional.
yeah. So SVD
Okay.
versions will be in the form of optional because we can't ask you directly to compute that because it will take a lot of time. So this is the second problem. Okay. So in exam, if you have been asked to calculate the SVD of any matrix, this is the best way to calculate is to calculate the eigenvalues of whatever the matrix like A has been given. So calculate A transpose A or A transpose, whichever is simpler for you. Okay. Whichever, like for example, if you had been given 5 cross 2, so calculate A transpose A, right? So it will give you 2 cross 2 matrix. And if you are getting 2 cross 2 matrix, just calculate the eigenvalues first and then take the root of that because singular values. Okay. And you can from the what you can say from the
Options we can
option you
choose.
can so
Yeah.
this is the best way to do. Somebody is doing like you're calculating q1 q2, it will take I guess 20 minutes and maybe I will be wrong in the end. Okay, so that's why it's very difficult to give the computation problem that will include you to solve all the q1 q2 and all. Okay,
Okay.
yeah,
Yes.
so please do that. So if BD has been asked, please solve first the best matrix like A transpose, whichever is better for you. And then like the first, use the first concept here, whatever has been discussed here. So use the basic smart concept to solve this. First, calculate A transpose or A transpose, whichever is suitable to solve, whichever is suitable to get the eigenvalues for that. And then take the singular values of the square root of both the eigenvalues and put it on the diagonal matrix. So calculate the diagonal matrix first and then match up with the answer. Okay. So you'll not be asked for sure to how to calculate Q1 and Q2 or Q3. Right? Okay. So doubt real system that time. So we have only NAT. So this time we'll not be having NAT all. So you will be having NAT like 40, 50% and 50% MCQ. So, but like for example, in the principal component analysis, so the principal component analysis, like you have to calculate the covariance matrix. So we can ask you to calculate the covariance matrix and do the summation of all the elements. That I can ask you, right? So it's the
Yeah,
covariance matrix, right? Covariance can be calculated like this. This won't take much time. So we have given you the problem in such a way that that can be solvable in 45 minutes. Okay, if you're going with the good approach. Otherwise, it will take you a lot of time. So all the problems, whichever can be kept in the MCQ or MSQ, like for example, there are some questions related to properties of like definiteness or positive definite and all. So those questions can be kept in the like NAT. So that we have kept in the MSQ. Okay. So this most of the questions are MSQ. If you are having very less question are MCQ, like okay, most of the questions are MSQ, like more than one can be correct.
right. Got it, sir. Thanks for the response.
Yeah. So SPD problem. So now it's not the time to go with the steps and all. So you should be able to calculate SPD with the help of your diagonal matrix. So you should be aware of how to calculate the diagonal matrix of this. When you are just decomposing the matrix, whatever you have been given, so just calculate, you should be able to calculate the diagonal matrix. Okay. Is there any problem in that?
So diagonal matrix is basically the
Like for example, okay, yeah, this is pretty simple, right? To calculate the diagonal matrix. So if you are being given this matrix, okay, 1, 1. So A transpose A or A transpose, whichever is simple. Like for example, for this example, A transpose is pretty simple to calculate, and from here you can calculate the eigenvalues, right? So you can calculate the eigenvalues of 16 and whatever this, and then you can calculate the this matrix. Okay. So,
nice.
so it should be not that difficult to calculate, and so one of the question is there, those will not include any more computation and all. So don't worry about the computation, just use some smart method to solve the problem. Okay. The PCA problem, I don't think so you'll be having issue. I told you the formula now. So please solve just whatever the problem is there in the graded or practice or mock, please solve those three and match up with the answer. The answers are not incorrect anywhere. So all the answers are correct. Maybe on the tutorial the answer may be incorrect. That I
Sir?
already told you. Yeah.
So can you share that PDF handout?
So this one, okay, I'll share this one. Yeah, I can share this one, but I need to remove some of the part because I just got it from some here. So I'll just remove some part and then I'll share it. Okay. Now, okay. So now we are moving to the, yes, I'll just share with the, I'll just upload the same file, upload this file on one link that I've shared earlier, where the solution, handwritten solutions are there. I'll just share it there. So you all have the access of that file, right?
Yes, sir, we have access to that.
Okay, so I'll just share it. And the next problem is that, okay, so I'll just, okay, this third point I'll go later. The fourth property, okay, property. So if you're having a positive definite matrix, so can we find the inverse matrix of that matrix, if that matrix is positive definite?
Yes.
Yeah, because the
Determinant
is
will
not
be
singular, right?
possible.
Yeah.
Yeah.
Okay. So anybody is having any issue in this? If this is positive and if this is a positive definite, and if I'm asking if this is a positive semi-definite, then whether it's a invertible or not,
Yeah.
it can
Then
be, it
we
can't
can't
be.
say.
Okay, yeah, we
Yeah.
can't say much about that. Is there any issue in this? Anybody is having any issue in this? No, right?
Hello, sir.
Yeah.
Positive definite means minima, right?
Positive definite.
Minima. The point is minima of the function.
Okay. Yeah, that's you're correct.
Yeah.
But don't, yeah, this is correct. So you can, yeah. So this, you can say the convex function. Okay, that's the one method to know. But if you are having given matrices, how will you calculate the minima? So don't go with that method first. So go with some basic method. If you have been given some matrix, okay. So first method is calculate the eigenvalues. Okay. If all the eigenvalues are positive, directly it's a positive definite matrix. Okay. That's the basic and simple method. If you want, because this will take like, if this is a matrix, like symmetric matrix, if you have been given non-symmetric matrix, you can directly say none of the above, because that in those cases you can't say. But okay, if you are having the symmetric matrix, first calculate the eigenvalue. Okay, and if all the eigenvalues are positive, then you can directly say this is a positive definite. This is the one and best method to solve this. If you want to, like for example, if you have been given the matrix, okay, like for example, A, B, C, D, E, F, B, and this C. Okay, and in this case, if A is positive, and the determinant of this is also positive, and the determinant of all the three, like this 3 cross 3 is also positive. If all the three are positive, then also you can say this is a positive definite. Okay, but there is a catch. Like if you have been given some negative in between, okay, then you'll get stuck. So it's better if you are getting all the three positive, okay, then fine, you can directly say. But if you are having in between some negative values and all, then then there are other like cats in this. Then you need to go through. There are 4-5 then properties in itself. Like if the number of negative thing is odd, then this is a different like character. It will behave in a different character. So it's better to solve this eigenvalues and get the eigenvalues. If all the three are positive, directly positive definite. If one is like if some is 0 also, then you can say this is a positive semi-definite, right? And like if it's a negative, then you can say a negative definite, and then if some is negative and some is 0, then you can say negative semi-definite. This is clear, right? If you have been given a matrix, you will not do any mistake. Right?
If positive definite gives minima, then what positive semi-definite give is minima or maxima? That's it. Like
okay, so positive semi-definite will give you a valley type of thing where one plane will consist of all the 0 value. Okay.
yeah.
Yeah. So this is a valley, and this valley is going like this. You can expect the thing I shown you right earlier also, and it has been there in the discourse also. So the figure of the difference between positive. So is there anyone who is having the figure of that positive semi-definite and positive
Yeah.
definite? I've already shown you, right?
Yeah. Like
okay.
Can we consider it as minima or
yeah, it's a minimum only, but that minima will be having a lot of values, will be having that same minimum. Okay.
Okay.
So
how the positive definite is minimum?
How the positive definite, I'm saying that this is the plot. This is what she's asking, I guess. This is the minimum point. This is what she's asking. And if you're having, like, for example, this is a quadratic equation, simple quadratic equation. So this is the minimum value, right? At this point. This is what she asked. And if
but
you're
sir,
having
positive definite is a matrix, so how this can be like minima? How can we relate both of the things?
Okay, so what are the function you will generate from this matrix? That function we are talking about, the character of that function.
Yeah, characteristic polynomial.
Yeah. Okay. So that's the one thing. Okay, and if you have been given the function, then you can calculate the Hessian matrix. Okay, that we have already discussed how to calculate the Hessian matrix, and then you can calculate the eigenvalues and all, right? Is this fine?
Yes, sir.
1 second. I'm just putting my.
So if the equation is given, the quadratic equation is given, then sir, we can from ABC we can also able to.
But this is a hectic method, right? We can solve. That's fine. Okay. 1 second.
But then, sir, please just once that Hessian matrix formation, and from that, how you going to conclude this positive? Just can you show?
Yeah. Oh. So what you told? Can you repeat that again?
No, I'm saying if some quadratic equation is given, say x square plus something is given, then from ABC we can conclude now if a greater than 0.
Yeah, that's the one method. Yeah, you can calculate like this. You can expand this x, y, z, and then x, y, z. This is the expansion you will get, right? And then you can compare the same thing, okay, with the function you have been given. Like the function you'll be having, and from here also you'll get a function, and then you can compare, and then you can write the value of a, b, c, d, right? That matrix you'll get. One method. We can calculate the Hessian matrix. That will not reflect you the same matrix. That will reflect you but that will give you the character of that matrix from that function. Okay, so it's better to go with the Hessian matrix. Calculate the Hessian matrix, and then you can with the Hessian matrix you can say regarding the function, which type of function it was. Okay.
So can you just show one example, sir? Then it will be easy for us.
Okay. So, like for example, what like okay. So there was one. I'll just write you some random values. Okay.
Excuse me, sir.
Yeah.
So some clarification here. So if all the eigenvalues are positive, then it is a positive definite. If all the eigenvalues are negative, then negative definite. And what about the semi-positive and semi-negative definite?
Okay. So for the semi-positive, positive semi-definite, you'll be having some lambda. You're asking about the eigenvalues only. So
Yes,
this will be including either, so one value out of the three will be a zero. One or more can also be zero. Like
at least one should be zero.
yeah, so no, yeah, it can include zero also, but in the PD it will not include zero. Okay, so here all the values will be greater than zero. For the negative semi-definite, the same thing will appear, but only the
Reverse
lambda is,
sign.
yeah.
Yeah.
Okay, for
And sir,
NHD,
what if all the eigenvalues are zero? Then what would be the matrix called?
the matrix will be PhD only. Okay, because here it is like all the eigenvalues are zero.
Yeah. Okay. At least. Okay.
Okay, but you can say this will come under PhD only.
Okay, sir. Thank you.
So yeah, so Hessian matrix he told me to calculate. Hessian matrix we have calculated. I'll just go through the same example that we have discussed in the I guess week 8, right? Week 8, where is that one slide? Week 9, I guess. The same way you have to calculate. Just the thing is, this is the difference. Yeah. So this you can see, right?
Yes, sir.
Okay. So this function, like for example, this function has been given, and then you have been asked to calculate anything. So you just have to calculate the Hessian matrix from this function. So Hessian matrix, I guess this was the answer, right? Will calculate the Hessian matrix. You know how to calculate. Everyone knows how to calculate the Hessian matrix.
Yes, sir.
Yes.
Okay. So Hessian matrix you can calculate, and then you can. So this you are getting some symmetric matrix, right? So you got already the symmetric matrix. Then calculate the eigenvalues of this matrix to get the. So this has been discussed in the week 8 or 9 also. To know regarding the convex, like PhD, whether the function is a PhD. So calculate the Hessian matrix and then see the eigenvalues. If you are getting all the eigenvalues as positive, you can say it's positive definite. And if you are getting lambda greater than equals to 0, then it's a PhD. Okay. So you can solve in this method also. If you have been given the function, right? Or you can say the function with some basic smartness also, you can calculate the matrix directly. Basic smartness means like if you have been given the equation like I forgot that equation. If you have been
So
given
Hessian matrix means first 1 position F triple X, then
okay,
F.
yeah. So we have been given this matrix, and if you are having like X Y Z is there, so X Y Z, and this is X Y Z. Do the double differentiation, partial differentiation with respect to this, okay, and then again with this, okay. So partial differentiation with respect to X. So you have to, with respect to X twice, the function you have to differentiate, okay. And then similarly here with respect to Y or with respect to X, okay. So the function you have to differentiate with the X and Y. Similarly here you need to partially differentiate the function with respect to Z and X. So either way you can do, either first you can do with X or then with Z, or the vice versa, Z or X. So you'll get the same value every time. And so the third here you'll get, so the same thing you can write it here, like the Y X or X Y you are doing, okay. The same thing you can write. And then again you have to differentiate the function with respect to Y twice. So here it will be the function with like the function, and you need to partially differentiate with respect to Y twice, okay. And the same way you can write. So is this clear, or should I write it this function?
Oh, it's okay.
Okay, right? So you can do this, I guess. So we're moving to the, so this clear. The next problem. Yeah. So if you are having this diagonal matrix, so whether this function is like, if I'm asking this D1 is like 5, D2 is like 9, and D3 is -1, then what's the property, like what you can say about this matrix?
We can't say indefinite.
Yeah, this you can't say anything. And if this is positive +1,
Then positive definite.
why?
Because all the eigenvalues are positive.
Okay, yeah. So if this type of matrix has been given D1, D2, D3, so this is a symmetric matrix also, and D1, D2, D3, generally if the matrix has been given in this form, or the diagonal matrix, so D1, D2, D3 generally represents the eigenvalues. So this can be formed, that this can be given in form of statement also. Like if there is a diagonal matrix, okay, and if all the diagonal elements are positive, then whether this matrix is a point definite, or some sort of other question can be asked, right? So there's no issue in this properties also, right?
Yes, sir.
Okay. So one question was there in the mock, I guess. I don't know whether this question is correct or not. That I need to check whoever prepared the question. So D1, D2, D3 was given, and some A, B, C, and 0, 0, 0 was given. So see, this matrix can be transformed. Okay, so this matrix has been asked to calculate whether this is a polydefinite or not. This matrix, I guess you can't say because this is not a symmetric matrix, whatever. Maybe this can be the transform matrix, the upper triangular matrix. In the upper triangular matrix also D1, D2, D3, I guess is the eigenvalues, right? Can somebody correct me? This is eigenvalues,
Yes.
right? Okay. So directly you can say this is a polydefinite if D1, D2, D3 is positive. But there is a one catch. There is a catch that this matrix given is not symmetric. And this matrix, because we are working on the symmetric matrix only till now. So for this is not symmetric. So I guess this is, we can't say anything about this. So that's the catch in this mock. I guess somebody asked me, Harshit asked me about this question. Yeah. So if you will not get such, there's the mistake, I guess, or maybe I need to ask this whoever has prepared this question. But this type problem will not get in the exam. Okay. So this was in the mock, I guess. So we were having the upper triangle matrix, but that was not symmetric. If somebody can say if I'm having a polydefinite matrix, so what if this is a positive definite? What will say about the S inverse? If you are having a matrix that is polydefinite, A is a positive definite. So what is that A inverse? Can somebody say?
Sorry, sir.
If S is positive definite, what is S inverse? Whether it's a positive definite or negative definite or PHP or NSP. If S is a matrix that is positive definite matrix, then S inverse is
Negative definite, I guess.
no. This has been discussed in last session. This S inverse is also
It will be
positive definite.
positive.
Yeah. Yeah, positive definite only. So this was discussed, I guess, in the last session. So we already forgotten, I guess. Okay. So this you can remember this some properties. Whatever I've discussed today, please remember this property. Like the polydefinite, if you are having the polydefinite, the inverse will be possible for that. Because why inverse is possible? Because the singular, this is not a singular matrix. Okay. And if we have been given regarding the diagonal matrix, you can directly say, right, whether it's a polydefinite or not. If you have been given S as an inverse polydefinite, then S inverse will be also positive definite. Okay. And this is the PCA problem that so what from the 7th week, so what the concept has been discussed. So PCA has been discussed, and from the PCA only some sort of problem, maybe some properties can be asked, right? Or some problem of this type can be asked, like you've been given data set and then you have need to calculate the projection matrix or the covariance matrix. So project covariance, everything I've discussed. So there won't be any confusion now to solve how to solve and what's the error. So please don't do the mistakes. We are talking like now we have already talked 3-4 times. So don't do that mistake in the paper if you have been asked to calculate the eigenvalues of the covariance matrix. Okay. Okay, so this was some important thing that was there in my mind to discuss, and that will help you for sure in the exam. The conceptual part I'm not discussing because this has been discussed already 2-3 times, so it's not good to discuss this again and again, right? So so these are some properties. I'll just share this also, but don't go through this. Don't go and read this, I guess. Yeah, we can go through this problem that we have discussed, some properties, whatever has been discussed in the lecture. So go through the slide one. From the properties can be asked from the 5th week and 7th week only. The P-shape property. So P-shape already you know the direction will be the direction will consist of the maximum variance or the minimum error. Okay, so that is the one property. Or what else that is in discussed. So the P-shape of problem can be asked. You have been given the x1, x2, x3. So I'll just go through the same questions.
Sir, in PCA, just can you just clarify once more, sir? Why the variance we are maximize?
Why we are maximizing the variance? Because see, So I need to go to the, okay. So, okay, so I'm having two, like for example, I discussed you the basic example. Like if I'm collecting the data of some 1,000 people from all over the India, right?
Hmm.
And then, uh, what was that? 1 second. What's that? And I need to calculate the weight of that portion. And I have whatever the data, what data I've calculated is height and the blackness of the hair, or you can say the length of the hair. Anything, like not the length, but blackness of the hair. Blackness of the hair means what? So the blackness of, so this simple example, you have to calculate the weight. There, the uh, hair color will not give you any result, right? See. Okay. So there are two features, feature one and feature two. In the final result, you need to get something. Okay. So this is the weight, I guess. This is the height, and this is the blackness of the hair. So blackness of the hair. So what do you expect? The people of the India will be having what? The gray hair, like the gray, like the hair will be mostly black, right? So the variance of this property will be what? If you will convert this blackness of the hair in some normalized, you are just normalizing this value, so you'll get some values between 0.9 to 1. 0.9 will represent the gray hair, and then 1 will represent the black, because the people of India doesn't have the red and blue hair, right? So most of the hair will be almost same for everyone. So this property is not helping me in calculating the weight of the person, right? So
Okay.
if this weight is not helping me to calculate the weight of the person, what I can do, I can just remove this feature. Why I'm removing this? Because there was no variance in this feature. So what I'm keeping those this height only to know the weight of the person, because in the height I was having a variance, right? The people height of the people will be what, from 5 feet to some 6.5, like for example 7 feet. So there is some sort of variance, right, in the data, right? So this is the data, this is the features that I'm keeping. So which feature I'm keeping? I'm keeping the which that feature only where the variance is maximum, right? So in the same way, the basic example I'm telling you. So I'm just removing those features only which are having the least variance. Okay, so I'm keeping the maximum variance content and I'm removing the least variance. If I need to go from 2 to 1 dimension. Similarly, if I have to go from some 10,000 dimension to 2 dimension only, so what I'll keep those direction only where I'm having the maximum variance, right?
Yes.
Are you able? Are
Yes,
you
yes,
with me,
yes.
right?
I'm getting, sir.
Yeah. So I'll just keep those features only where the variance is maximum. So I'll just keep this variance and this variance. So with some computation and all, I'll get to know that the eigenvector that I'm getting for these two values, I'm getting from the eigenvalues that was having the maximum value. Like for example, lambda 1 and lambda 2. Lambda 1 and lambda 2 was corresponding the maximum, two most highest, the matrix with the highest magnitude. Okay. And corresponding to this matrix, whatever the eigenvalue, the eigenvector I'm getting, it should be the direction where the maximum variance is there. Okay, so I'll just keep u1 and u2, and I'll just remove all the other vectors. Okay, so that's why I'm just keeping the direction which is having the maximum variance, or you can see in the other way, the where the minimum, the reconstruction error is minimum. Okay.
Yes, but sir, it is correct that you are taking the maximum eigenvalue, the eigenvector corresponding to the maximum eigenvalue, so that you can able to go to the most dominant direction. But when you calculate the variance, you are actually adding all the eigenvalue. Why this?
When you are calculating the
Variance, you are actually adding all the eigenvalues.
okay, where is that? Where you are calculating the variance of all?
And that is in the lecture that I find, sir.
Mm, okay. Okay, projected variance you're asking. This is a different, I guess, thing. See, what I told, like, for example, I'm having this lambda. So projected variance, I don't know what is the significance of projected variance. Okay, but one thing I will tell you, like I'm having I was having three features. Okay, three features, and not three features. Like for example, I was having some n number of features, and the eigenvalues what I got is like some 10, and then this is 1, and this is 0.5. Okay, so when I'll keep this, so how much percentage of information I can keep? So this generally represents 10 plus
11 by
0.1 plus
11.5.
yeah, so 11.5. So this is the percent of information I am keeping while removing this two dimension. I'm just transforming this three dimension into one dimension. I'm keeping this much of information. There's no significance. I guess the projected variance, the summation of all the projected variance is simply the, I guess the projected variance is calculated for each of the transform value and then has been added, I guess. No, so I need to check what's the significance of that thing because I didn't read that. I need to go through that. Okay. Yeah. So this is the thing. Okay. So Advait, which is, for example, this is a question. Okay. I'll just go through this question and let me know if you're having any issue. So here also, see the problem is here also, I guess. So has somebody rechecked this original transformed also? I guess there is an issue here also. So have you solved this problem, Lee, John? Have you solved this one?
This one, no, sir. I did not.
Oh, okay, so if you solve, so what are the answer also given in the tutorial? John goes to that. Okay, like the method is correct in the tutorial. Maybe but there are calculation error here. Like for example, here the eigenvalue is the 14 upon 3, but the eigenvalue is correct. Eigenvector is correct. So the eigenvector, what you will get? Because the eigenvalue here is the maximum, so you'll get the because if you divide with 3 also all the places will have this will be having the maximum, what you can say, the magnitude, right? So the vector whatever you're getting correct. So the basic method is what you are having the data set. You have got the data set. So for example, you have been given 3 data sets, right? So x1, x2. Okay. Now what you have to do, you have to calculate the mean. That is simple, right? So you can calculate the mean vector very fast. That's simple. Okay.
So is the covariance matrix always symmetric?
Covariance matrix will be symmetric, yeah.
So
But
always in all the
will be
cases.
symmetric because you are doing some x transpose A, right? In the covariance, what is the formula of that x? You are doing what you are, yeah. Okay, so you are doing that x transpose A, right?
Yes, sir. Okay. And sir, can I ask my questions now?
Yeah, you can ask. Okay, so you can ask. Till that time I'll just discuss. So he's asking how to solve this PCA problem. So just go through that. Okay, once. So this is a data set. It's for example, it's for everyone. If you get this data set, for example, x1, x2, x3. Okay, so if you have been asked to calculate mean vector, you can calculate mean vector. Covariance matrix, you can calculate. This is a simple formula. So 1/3 that x minus x bar ka x minus x bar and then x minus x bar ka transpose that you can calculate. You'll get the covariance matrix here. Then you can calculate the characteristic equation to solve the eigenvalues. Like if you are having 2/3 here, just multiply 2/3 every time. Okay, like for example here 2/3 minus lambda. Okay, and then you can multiply here also. So this will be 4/3. So similarly you can do for all the values and then calculate the, or you can calculate the eigenvalue divided with 2. So multiply it with 2/3, right? You'll get this eigenvalue, eigenvector you can calculate, and the projecting data set. Okay, so this is the one thing. So if you have to calculate a transform data set, what you will do, you will just remember the formula x transpose u1. So you'll get some constant value and then multiply with the u1, the vector you have got. Okay, so x transpose u, x transpose, like for example, you can calculate for first transform value x1. So you transform the x1, like whatever the data set you were given earlier, and then multiply with the unit vector, not the unit vector, the vector that you have calculated. The first vector corresponds to the most eigenvalue. Okay, if you have to transform one dimension. Okay, you'll get this, and then reconstruction error is the basic formula 1/3 summation for all the xi minus x tilde. Xi is the basic data set and x tilde is the projected data set. Okay, and the projected variance is how? What is the formula for projected variance? Can somebody say?
So here they basically add all the eigenvalues.
Okay, so you have to calculate the eigenvalues to calculate, but for the significance I'm not getting. What is the significance of this? Okay, so if you have been asked to calculate the projected variance, you can do the summation, but I need to check the significance of this. Okay, so then
Sir, can you repeat step 7?
okay, I'll repeat the step again. So you have been given data set. First, calculate the mean vector. Why you are calculating the mean vector? To calculate the covariance matrix, because in the covariance matrix there was a formula x minus x bar. X bar is what? Mean value, right? So x minus x bar multiplies x minus x bar ka transpose. So x is the data set, x bar is the mean vector, right? And 1/3 is the symmetric matrix. Sorry, the basic formula of the symmetric matrix is 1/3 x minus x bar into x minus x bar ka transpose, right? This clear? Covariance matrix you can calculate. So now you need to get the characteristic equation. To calculate the characteristic equation, I told you, if you are getting some eigenvalues as covariance matrix as A, B, C, D, like for example here it is 1/2. So what you will do to calculate the eigenvalue? Do like this: A/2, C/2, D/2. Then do minus lambda. Okay. Then calculate the characteristic equation. That is what? A minus 2 lambda into D minus 2 lambda minus CD by 4 equals to 0, right? So this you can write, and then calculate the lambda 1 and lambda 2. So you will get the eigenvalue. Corresponding to that, you can calculate the eigenvector. Okay, eigenvector, I don't think so. It's required to solve. Okay, so if you have been asked to calculate the eigenvector, you can calculate the eigenvector in normalized form if you have been asked. Otherwise, if not asked, there is no use of this in the like projected data set. No, projected data set, you have to calculate the eigenvector also. Okay. So U1 you have to calculate, and U2 also you have to calculate. So corresponding to lambda 1, you have to calculate U1, and corresponding to lambda 2, you need to calculate U2. Okay. And then for the projected data set, the basic formula is X1, like if you are doing for the X1 tilde and X2 tilde, X3 tilde. So X1 tilde, X1 transpose into U1. So this is a constant value, and this you need to multiply with Q1. Okay. So this is the projected data set corresponding to the X1. Similarly, you can do for the X2 tilde, X3 tilde. You will get the projected data set. Now you have to calculate the error. So I will calculate the error. Error 1/3 because you have 3 points. And then you need to xi minus xi equal tilde ka whole square. Okay, so do the summation for all and divide with 3. You will get the reconstruction error. That you can
So
go
for
to
x2
the, yeah.
So for x2 tilde, we have to use u1 only, no?
Yeah, every time you use U1 because U1 is the direction where you are projecting everything, right?
So the highest eigenvalue, the corresponding eigenvector for the highest eigenvalue you have to use here, no?
Yeah, so if you have to, you can, because you have been asked, so okay, so U2 you not have to, you don't have to calculate because U2 is not required here. Because you have been asked to calculate from 3-dimensional or whatever the dimensional to 1-dimensional, but 1-dimensional you will be considering only lambda 1, and lambda 1 is the eigenvalues corresponding the maximum eigenvalues, and U1 is the eigenvector corresponding to the maximum eigenvalue. Okay, is it clear now?
Yes.
Okay,
Yes.
so you can practice and then you can push it on the discourse.
Sir,
Maybe we can discuss it. Yeah.
So if these points are given in the instead of real plane in the complex plane, then they are this x1 transpose. We have to take x1 conjugate transpose, right?
Yeah, but this is not been given in the form. This will not be given. This will become a very complex problem. Don't
Okay.
go. Yeah, so just
Okay.
try to solve with the real problem also. So
Okay.
if
And
somebody
sir,
can, yeah, so somebody can just take some values and just solve all the process and put it on the discourse. Maybe that will help everyone. Because many of you are having the issue. So maybe some of you can solve and then we can take it there, right? So maybe is it
and
fine?
sir, one more thing.
Excuse me, sir.
If the data is already centered, then no need to calculate that x bar, right?
Yeah, if the data is centered, that means, so why no need to, you have to calculate the x bar, right? So you have to calculate, you will get 0, 0, 0, right? Because
0, 0, 0.
So that you have to use to calculate the covariance matrix, right?
But
That is not
then
for of use. Yeah. You can say
in
that.
question, how do you communicate the data is centered?
If your data is given like this, like x1 is like -1, 0, and the data is 1 0. We'll be having 10 0 0, right? X bar.
Okay. Okay.
So suppose we have to calculate for 2D PCA. Then, sir, what eigenvectors we should have to take? The two largest.
Yeah, we have to calculate the two largest eigenvalues. Yeah, correct. But that will become a bit
and
complex.
sir, for the
say.
And for three-dimensional thing also, if we have to take all three. If we have 3x3 covariance matrix.
Okay, so if you have to calculate from d-dimensional to 2 dimensions, you need to calculate lambda1, lambda2, and u1 and u2. If you have to calculate from d-dimensional to 3 dimensions, you need to calculate lambda1, lambda2, lambda3, and u1, u2, u3. But just concentrate on only 1 dimension. So if you are able to solve this, that is more than enough. Because it's like, why somebody will ask you to calculate 2 dimensions? Because you can directly do with the help of some basic code, right? So just for the conceptual purpose, they'll ask.
So in exams, we'll have.
No, you'll not have. So if you'll have, if you are having.
We'll have only 1 dimensional.
Yeah, so you'll be having only 1 dimension. Don't worry about that. So you're having basic code.
And sir, in SVD, if the matrix is given 3x3 initial matrix, then from that, when we are calculating, means constructing this A transpose A or A transpose,
we'll get
then we need to go through this Gram-Skid process now to find all the orthogonal component in that matrix.
Okay, yeah, you have to not Gram-Schmidt. Okay, if you are getting some zeros here, then that will become complex. If you are not getting any eigenvalues as 0, you can calculate the eigenvector directly, right? If you are getting some 0 in between, like for example, lambda1 is some A, lambda2 is B, lambda3 is 0, then you'll be having pain to calculate. But if you're not having lambda A, B, C, all are given, so you can directly calculate this U1, U2, U3, right?
Okay, on that time, I don't need to go for the Gram-Skid because by divide by norm, I can able to set the orthonormal.
You can directly calculate this. But yeah, so this is the method to calculate Q1 and Q2. But the diagonal matrix can be calculated directly, right?
A diagonal can be calculated.
So if you have been asked to calculate the Q1, Q2, then you need to go through that. But that, see how much time it will take. If you have been given 3 questions from SBD of this type, it will take you 40 minutes, right? So how can somebody ask this type of problem?
Okay, that means in Gram-Skid, we don't expect in exam, right?
Yeah, so you should not expect, and it's not given also. Will not be given any complex problem that will take you. So all the concepts are conceptual. That is just like.
So can I ask my questions now?
Yeah, sure.
Okay. So I have problem in quiz. Sorry, in mock questions. Yeah, mock.
So this quiz is going to be optional, right?
Optional means if you have already given, right? First you have given, right?
Yes, sir.
So if you are attempting or both the quiz, the method to calculate the marks is different, and if you are attempting only one, the method is different. I don't know whether this will make you impact. It's better to go and write this paper, right? So you need to go through that, please.
But sir, actually some days ago we got a mail that end term marks will be prorated and all.
So end term marks?
Prorated to quiz marks, is it?
I'm not aware of that. I need to check the grading pattern, then only I'll be able to tell you. If somebody is not attempting this, what will happen?
I mean, if you attempt it and if you have a better mark in this quiz, then you have more leverage, basically.
So the mark grading pattern I need to. So you can just mail me once. I'll just go through it. After this meeting, I'll go through that. Also issue. But there is some different like calculation method if somebody has written both the. So there is some benefit, I guess. when last time I don't know, this time the method hasn't changed because of the bonus marks and all. So yeah, so one more thing, the reflection problem and all, will be having more questions from 8th week, I guess. So reflection problem, some 1 or 2 problem in each week. So and from the discourse itself, okay. So maybe next week we'll get and you can solve this. So the deadline will be also provided. So which question you are asking? I guess he's waiting for so long.
So in question 1, so how can we say that the matrix Q will be multiplied by K, not Q star and T?
Okay, so what is this decomposition for a matrix? It's Q given Q T Q transpose. If it's multiplied by a constant K, then expected decomposition will be. Okay, so what's the issue in this?
So here, if we are multiplying S with a scalar K, then how can we say that K is going to multiply with Q only, not with T or Q star?
It's multiplying with T only, right?
Yeah.
It's not getting because the magnitude of Q will get changed. Q should be unitary, right?
Yeah, Q is unitary.
So if you are multiplying K with Q, so that will become the K, the magnitude of that Q matrix will become K, right? Or the Q transpose. That's why it can be multiplied with only K, T only, right?
No,
are you
sir,
getting my point?
No, sir, no, sir.
Did you get the point?
No, sir, I didn't understand.
See, if I'm multiplying with S, so S is what? Q transpose, right? Q
Yes,
and
yes.
Q transpose is unitary matrix. So only T, so whatever if I'm calculating whatever the magnitude of S is there, that should be the magnitude of T, because Q and Q transpose is unitary matrix, right?
Yes, sir.
So if I'm multiplying anything with S, that is directly getting reflected with T only, because if I'm after like for example here, K has been multiplied LHS and RHS also. So if I'll calculate the magnitude, so Q and Q transpose will be unitary every time.
Yes, sir. It will be I.
Yeah.
Identity matrix.
Correct. So
Yes,
only
sir.
that K is getting multiplied T only, right? Because Q and Q transpose is unitary. If I'm multiplying anything with that, it's not going to be so. If I'm multiplying some matrix with unitary matrix, I need to normalize that. And if I'm normalizing that, the K will get divided, right? So the KT only that K should reflect with T only. So it should not be multiplied with Q. So it's like directly you can say anytime you'll get some question like this, you can directly say like Q and there won't be any change in Q and Q transpose, because if I'm multiplying with T, so I need to divide that also to normalize that, because I need to get that.
I understood.
Yeah, got that one. Okay.
Yes, and the second question, sir. So in
second
this
question, so there, okay, yeah, what's the issue in this? So this has been calculated, right?
So yeah, I didn't understand how this 8 comes.
Okay, so the values here is different. So whatever the solution you are having, I guess some question
No,
is
so solution is same. The values are same.
So the solution, what the solution is?
So the values which I got in my solution are same as yours.
Okay, so what's the problem then?
So I understood this. We have to find the determinant of S. So this distribution also, this second step also I have understood. But how this determinant of sigma came into existence and how it's getting the value 8.
Calculate that. So sigma you can calculate that just by multiplying this T. But other factor you need to calculate. It's a very complex question. I don't know who prepared this. Does anybody has any other?
So how this determinant goes to 1? I didn't understand. U and V transfer. U and V transfer.
So this one, the main diagonal. We can directly calculate the lambda 1, lambda 2, lambda 3 because that is the square root of that.
So that we can directly multiply d1, d2, d3, right? So this we can multiply directly
and square it.
Okay, and this is a unitary matrix, that because this is a normalized form. So every time you are doing the SPD, you are normalizing this and this one. So this will be having the magnitude at 1, 1, right?
Yeah.
Did you get the point? So if this is the question, U and V.
So sir, can you explain it once again, sir?
Okay, so when you were calculating the SPD, So you were after calculating the vectors and all, you're just normalizing this what u or q1 and q2, right? So
Yes,
normalizing is what you are making that vector the unitary matrix,
yes,
right?
yes, sir.
Okay, so u and v become q1 or q2, q and q transpose whatever the value you are taking, that is
Yeah.
unitary normalized, like what you can say, unitary matrix. So the
Yes, sir.
magnitude will be one, right? So all the
Yes, sir.
magnitude will be getting reflected from the diagonal matrix only.
Okay.
And the diagonal matrix is here. In the diagonal matrix, you can directly calculate the singular, what do you mean, the magnitude of that diagonal as the multiplication of that eigenvalues or the multiplication of the diagonal element. Okay, so you can just
Yeah.
multiply this three to get the.
Okay. Okay, sir.
Okay.
And sir, in this question number 3, so
Okay.
question number 3, I have calculated it, but I have got A as, so if you can just write down anywhere, then it will be easier for me to explain.
Okay, so the matrix A is Hermitian for all the values of A. Just written trial method can also work here. Only for some values of A.
So I have used trigonometric identities here.
So, okay, tell me the basic properties of Hermitian matrices. What are the basic properties of Hermitian, and then try to fit it there. If so, without okay, so this is what this is, I guess, sin x, right?
Yes, sir. Yes, sir.
And this
No,
is,
sir. It's cos
cos and
theta.
sin.
Yeah, this is sin.
Okay, so this is cos and this is sin. Okay, in the last, I guess this has been discussed in the last revision session, but okay, it's fine. Okay, so what are the basic properties of Hermitian matrices?
So for Hermitian matrix, the matrix and its transpose conjugate is equal. So, if A is a Hermitian matrix, then A is equals to its conjugate transpose.
Okay, so don't do with this matrix, whether if you are able to do that or not with this matrix, with the sine and cos, whatever you are taking, without taking any theta, and just see that whether it's possible or not. If this is possible, then you will be Hermitian for all the values of theta.
So, sir,
Right?
should I take it sine or cos, or should I solve it like this only?
Like this also you can solve or the sine, because this is the same representation of sine or cos. So you can take sine or cos also. There is no issue in that.
So if you can just understand from here only, this A11 is cos theta, and this A22 is I sine theta.
Okay, so this is correct,
No,
right?
no. It will be sine theta. Yes. I
Yeah,
got
so
I got my,
some
because
mistake.
I is present here in the denominator. I got it wrong. So yes, I got the answer. And sir, this question number 4 also,
Okay,
I didn't understand how the solution goes on.
okay, so it is known that the operation z dot z, where z belongs to some complex matrix with n dimension, and always outputs a real number. Then the resultant scalar for the operation z dot is where A is a Hermitian matrix of this. Okay.
So we can take an example, like a general example, and do it, right?
Okay, that's the one thing. How they have solved this?
So can we write this Az equal to lambda z?
Az equals to lambda z. How can you write that? Because A is not the diagonal matrix, right? A is a Hermitian
No, this is
matrix.
Hermitian matrix.
Yeah. For Hermitian matrix, you can't write, right?
What's the Hermitian? What you can't read?
How can you write Az equals to lambda z? Okay, so if you have to calculate something, Az equals to lambda z, when I guess you can write. Yeah, you can write that.
Yeah.
Lambda z. You can write. Yeah, correct.
Yeah, then sir, why should I go for this solution? Lambda z means lambda is scalar, and so I can take this lambda out, and z dot z they said real, so any real into scalar is real.
That's also correct. But, okay, so here what they have did, that is also fine if you are writing Az equals to direct lambda z. That's the basic properties of any matrix. Okay, because, yeah. and then where that is output, then the resultant is scalar of the. Okay, so what has, okay, so this is Hermitian matrix, right? So that's what he has done. Mean the operation z dot z where z belongs to complex. And this, one thing you can do is you can take some random, but that will take a lot of time to solve this.
No, sir. It will, like, you can take a small set, right? Like for 2 by 2 or something. Like if
Okay.
A is 2 by 2 and if X is like 1 by 2.
Okay, so A you can just take some I, right?
Yeah, something like that.
Okay, and then you'll calculate. Okay, yeah. So that, okay, yeah, this is also good method. Yeah, you can do like that. So you can just take some matrix. A is very small matrix, okay, and then you can calculate this.
And in the end, like we can see that what happens is the non-diagonal elements basically cancel out because they are the conjugates of each other, right?
Correct.
So they cancel out. And then we'll get just the leading thing. So when that happens, like you have real numbers along the leading diagonal, and since the z before the dot product, the thing will become z star. So z star times a scalar times z will become like obviously a scalar because it will become that scalar times z dot z, which will obviously be a scalar.
Please explain we've already discussed. So is it who was asking question?
So I was asking the question.
So you can just take some A and then you can do that. Maybe that will help you to solve this problem.
So sir, taking any random example like A and Z. So any complex number Z, complex matrix Z and
Simple
A.
complex matrix you can take some Z and then A also you can take and then you can calculate this. I guess so. In the exam also you are not getting anything. Just take some random stuff and solve. I guess you'll get the real value only, real number only.
Okay.
You can try with that
I'll
method.
try.
Some basic hit and trial method. But I don't know how he has
So how this thing performed here, how this came into existence, I didn't understand this thing, so I asked you
solution,
this
right?
question. Yeah.
Solution maybe from wherever he is, because like I don't know from where, but this is also correct. But how will this try? It's better to the basic approach. Just take the some Z and A and then calculate. That would be I guess the correct. But that will take a bit time, but fine.
So one last question.
Okay.
So it's from graded assignment, week 8, graded assignment, question number 2.
Week 8.
Yeah.
Week 8 question number. What is that?
So it's question number 2.
Question 2. The point on this project is 0.2.
So how to form the characteristic polynomial here?
Okay. So what is that characteristic polynomial you can?
To solve in practice assignment solution, they have given the same problem.
What?
Same problem is given the practice assignment also. So they have solved it and given solution.
Yeah, solution for graded 8 also present, but I didn't understand. They have directly written the characteristic polynomial. How they form it, I didn't get that one.
Practice assignment is solved clearly.
The practice with 8 week, right? This question, right? So what is the objective? Okay, this is the unconstant equation.
So the objective function they have written directly. I didn't understand how this came. X square plus 1 minus 1.
So you need to calculate the closest point from there. So you need to calculate closest point. Let, for example, the closest point is x and y in this plot, right? Let, for example, this is x and y only in this plot itself. So there's a plot that is y equals to x square plus 1. So we need to, like, for example, if you have to calculate some distance between 2 points like x and y, right? This is what has been given. So to calculate the distance, so x minus 0 ka whole square, that generally you calculate.
Okay, this is the distance formula here.
Yeah, this is a basic distance, and y minus 1.5. So y is x square plus 1 whole square. So this is b square, and then you need to calculate the minimum.
Okay, I understood. So I thought there's something else used here.
These problems are we can solve without setting the objective function also, right?
Yeah, without that also you can solve. Like without objective, like if, for example, just forget that we have been discussed this objective function.
How can we solve without objective function?
Then
actually, what I did, I just set the tangent equation of any point in the parabola, say any arbitrary point x comma x square plus 1.
But for that, you should know that the tangent equation of the parabola, right? There is a formula for that also.
No, sir. You can just differentiate it and you can get it.
Okay,
differentiating it, yeah.
Okay. Yeah, you can get that.
You get one straight line because of that tangent. And now from that point, you draw this 0,15. You draw a straight line formula, calculate the M1 there and calculate the M2. M1, M2 is equal to -1. You can solve that.
Yeah, that also you can solve. So what you will do, there is a parabola, right? So this parabola is there and there is some point. So you will calculate the tangent here and then the perpendicular distance from that point, right?
Yes.
Perpendicular line, and that line and the slope of this line and slope of this line. If this is minimum distance, then it should be perpendicular. And for perpendicular, there is a basic formula there. M1 and M2 should be equals to -1. This is a straight line generally we study in class 10. So that you can do. So the slope of this and slope of this, you can multiply and then equate it to -1. We will get IB script. Right? This is the approach, right?
Yes.
Okay.
So sir, for this perpendicular line, we have to use some formula for a point and a line distance formula
so dy dx
of a point to any line.
So this is the dy dx at this point, like for example at x comma y itself, and this is the point.
But for this line, the perpendicular line on the tangent.
This is the xy, right? This xy I'm taking on this point. This parabola. So this parabola is what? X comma x square plus 1, and this is the point 0 comma what is that point? 1.5, right? So if I'm having this x1 and x2, sorry, x1 and y1, and this x2 and y2, you can calculate the straight line passing through 2 points, right? Or you can say the slope also. Slope, how is that calculated? y2 minus y1 minus x2 minus x1. So this is the slope of this. So what is that? So what is that? y2 is x square plus 1 minus 1.5 upon x2 is what? X minus 0, right? And this multiplied with this 2x is equals to minus 1, right? And then we can solve. I guess this is the method.
Yes, yes. Thank you. So I'm done now.
Okay. Okay. So okay. So whatever I've discussed today. So see, 3 plus 3 I already discussed. Whoever was asking the problem. So Pralay, I've already discussed 3 plus 3 matrix, SPD and PK. What can you expect and can be asked in the exam? Okay. So now past so from now you are having only 1 day. So what you can do is you can just solve the last term quiz 2 problem. And so last term what happened? Last term I guess the concept was from 4 to 6. Okay. So you can just 4 to 6 means you can just go to the last term quiz 3 also. Last to so you're having access of last term or last to last term also. So do you have problem of the last to last term, like both you're having, right? So you can
I
do
think
the
we
both
have till October 31st.
last to last term you're having, right?
Yeah,
Yeah.
yes, sir.
Okay. So last to last term also you can just solve the problem from 4 to 6 which is there in the quiz 2. And in quiz 2 also there would be some problem of week 7. Okay. Solve that also. So this, so do 4 things from now if you don't have the time. So quiz 2 of last term and quiz 2 of last to last term. And last to last term, you solve the quiz 3 and from the week 7 also solve those problems. So this, if you're having solution, just go through that and then solve this 5-6 problems that I told you from week 6 and 7. So you won't, I don't think so you'll mistake any problems. You're solving all these problems, okay? And this 5-6 problems plus quiz 2 of last term and last term. That will suffice to week 7 and 7, 6, 7, 7. For week 5, you're already solving this quiz 2 of last and last term. That is more than sufficient. And for that 8, you can solve the graded ones again. Okay. And you're already solving this last term quiz 2. So that is more than sufficient. Okay. So I don't think so from if you're solving this, none of the problem you should mistake in the exam. So you'll get the question, most of the question on the same page. Okay. Same sort of problems, maybe data may be changed or same problem with different context. Okay. So I guess
Where are we having the last term quiz tools? Questions or solution?
quiz last term, right?
Yeah, you were talking about that. Do we have that?
So somebody has shared, I guess share. I remember this.
Okay. In the
So
discourse?
if somebody is having, please share that on the
It is there in the chat, I think.
Yeah, so you can go through that. If you're not finding that, you can post it on the Discord. Maybe someone from us can post it there also. Okay. Is that fine?
Yes, sir. Yes.
And everything mock solution graded, everything has been uploaded. Week 9, 10 also uploaded, but now it's no point to go through week 9, 10. So till 8, just do that and then we'll discuss all the others from next week, maybe from Monday. If you're having any doubts, then you can just mail or post it in the Discord. Maybe by you have
Share that PDF sir handout.
I'll share this PDF on the Discord. I'll just
If you
upload
can
it.
upload it here,
that.
sir. Upload in the chat, then we can download it.
Okay, I'll just upload it. I'll just upload it there after this meeting. Or else I'll just,
where, sir?
Okay, I'll just.
So putting it on the discourse might be more. We can access it later as well.
Yeah, so I'll just upload it on the one G drive and post on the Discord in 10 to 15 minutes on the Discord itself. You can just use it.
Okay, sir.
Okay, if I will not, you can just ping me on the mail or anywhere, like phone number also, you can just message me, I'll just upload. So somebody from you generally message me to upload that. Then I also remember, like most of the time I post it, like pass it to the portal team also. But if because tomorrow is Saturday and all, so I'll just post it on the G drive itself. Okay.
Yes, sir.
If you have any more issue, you can just ask me anywhere. Till tomorrow you have the time. And whatever I've discussed, I don't think so. The concept will be from apart from this thing, because these are the most like problem that can be asked in the exam. I guess the 6th, 7th I've already covered everything. 8th mostly that graded solve that graded problem. So from 8th week, maybe you can expect those type of problem, the minima and minima distance. Okay, those you can solve. So NAT problem will be there from those weeks, because you will not get any very much the question that includes a lot of calculation, like Newton Raphson and all, like you need to calculate for fifth iteration and all. So those problems not there. So don't worry about that.
Sir, what about that Newton's method?
So you'll not get the question that consists of like fifth or sixth iteration. Okay, so you'll get question that can be solvable in first iteration itself. So don't worry about that. So basic formula, use that formula. Like this first iteration also. If there is any question, we'll get there won't be any competition like difficulty in the competition. Okay, so all the competition are pretty simple. Only the smart approach, or you can say the basic properties should be able to make. Okay? And you can go with, from this slide also, whatever the problem has been discussed here, you can solve these problems also. Okay, in the slide, whatever is there. So maybe to clarify your doubts. Okay. If anything else is there, you can ask, or else you can message, or whatever you want to do, you can do. We just discuss it there. So, is it fine? Does it include papers with solution also? I guess the solution is also there, right? For the last quizzes, right?
Yeah, it is. It is actually the solution thing that is being uploaded. So
Okay.
I mean, solution in the sense just the answer. The working is not there, just the answer is there.
Okay. Okay. So maybe you can. Okay. For which of the okay, I'll just check, because I need to go through that again. The file, source file. I'll check whether it's available. I'll upload. Otherwise, it's already, because I guess it would be with someone from. There would be some people will be having the solution also. So for me, I need to check the source file. So every time we generally like prepare the solutions also. But for the last, I guess last term, and we didn't prepare the solution. But earlier we used to prepare the solutions also. If there is any conflict in the questions and all, you should prepare the solutions.
But solutions to, like, I don't know if for each set it would be available, because because it might be a small, like, variation of this thing, right? Like for each set and all.
So all the weeks solution has been like uploaded, right? All the gradient practices.
Yeah, that is
okay. So I guess we are done with today. If you are having any issue, you can ask wherever you want to. Like you can mail or WhatsApp me, and just mail it, like reply it there. Fine.
Yes, sir.
All the best, everyone.
Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Thanks, everyone, and all the best for
Thank you, sir.
Thank you, sir.